Okay, so what we're going to be talking about today is evaluating algebraic expressions and being able to find equivalent algebraic expressions. We'll talk a little bit first about faces of equal, some of the things that you saw on there, and maybe give you some hints. Those of you that were in first and second period, you've already seen this. We've had this conversation. But what we're going to talk about right now, we'll be reviewing that. And then for those of you in B8, you can look at this, and then it should tell you if you're doing the right things or not in on the faces of equal worksheet. So if I look, let's just start off with the stuff from faces of equal. It is a simple concept that, look, if I have 4 plus 7, that equals what? Now, most of you know that 4 plus 7 equals 11, but this equal sign has some power to it, because it doesn't just mean it equals 11. It's not just the sum of what the other side is. 4 plus 7 also equals, could be 8 plus 3. 4 plus 7 could also equal 12 minus 1. 4 plus 7 could also equal 22 divided by 2. All of these expressions, this expression, these two expressions are equivalent. In other words, they come up with the same amount. So this is 11 and this is 11. This becomes 11. This becomes 11. So all of these are equal. So if I were to write this out and say, well, 4 plus 7 equals blank plus 3, which equals blank minus 1, which equals blank divided by 2, then what you would do is plug in, well, we already realized this is 8 plus 3. And we've already discussed that this also equals 12 minus 1. And this also equals 22 divided by 2. Because 4 plus 7 is 11, 8 plus 3 is 11, 12 minus 1 is 11, and 22 minus 2, or divided by 2, is 11. These are all equivalent expressions. So if I look, this is equal to this, which is equal to this, which is equal to this. So ultimately, it's equal 11. So now think about that for a minute. When you look at your faces of equal, how does that change your answer? When you look at number 4, you should see that some of you may have made a mistake. Because many of you may have said, well, if I have 4 plus 7, now I don't believe that's the number they had, and then blank plus 3 equals blank minus 1 equals blank divided by 2 equals, some of you may have made the mistake of saying, well, that's going to be 11 plus 3. And 11 plus 3 is 14. And 14 minus 1 is 13, which means 13 divided by 2 is going to be 6.5. But that would be incorrect. That means you don't understand that we're including this whole thing, because this side equals 11, and this would equal 14. This would equal 13. And as we just said, this is equal to 6.5. These are not equal to each other. So you have to understand that if you filled out number 4 on faces of equal like this, then that would be incorrect. This upper model is how you should have filled out faces of equal. Of course, you had different numbers. So let's try another one of those. So now look at this one. to write this out in your learning journal. You should be writing this on page 40. Now fill it in. Okay, so you're going to pause it for a minute just so you can fill it in and discuss it at your table for 2 minutes. Okay, so if you pause this, you should have discussed, and what you should be coming up with is that this equals 18. So this needs to equal 18, and this needs to equal 18, and this needs to equal 18. Because that's what this equal sign means, is that these expressions here, here, and here are all equivalent to this expression here. All 4 of these expressions need to be equivalent. So you should have come up with that this would be 7, that this would be 6, that this would be 24. Okay, so hopefully that's what you came up with. If you have any questions, go ahead and pause it now and answer any questions you might have. So this should give you some thought for when you look at number 5 and number 6, because now you have choices. Now you have to look and say, if I had 12 minus 7, what are the possible outcomes? What could be on this other side, on the right-hand side of this equal sign? So pause for a minute and think about that. Write down some of the things after you look at what we did here, what are some of the things that could be in place of 12 minus 7? So pause for a minute and write those in your learning journal. So the question is, what else equals 12 minus 7? And hopefully you've already come up with some and discussed it in your class. And if I look, I might say, well, 12 minus 7, first of all, 12 minus 7 is 5. So what are the other things that would equal 5? Well, I can think of 40 divided by 8. I could say 16 minus 11. I could say negative 8 plus 13. All of these equal 5. And so those are all equivalent expressions. That's what the power of this equivalence means. It means those two are equal. Both sides have the same value. So now you need to think about that a bit, and we'll continue to move on with that. But you need to think about how that affects question 5 and question 6. Okay, go ahead and discuss that at your tables. You should take about 3 minutes to discuss that. Okay, so now what we need to do is we're going to look at these problems here. Now what we see is 1, 2, and 3, those are the ones we're going to focus on. What they've asked us to do is we need to evaluate each expression. So we're going to evaluate each expression if m equals 2, n equals 6, and p equals negative 4. So now this is the thing that we've expected that you've already been taught. But you're going to need to know how to do this evaluation when we talk about two things that are equivalent expressions, because we want to take those two equivalent expressions and we're going to evaluate them by using a number. So we're going to practice this evaluation. Now, again, just to kind of show you, give you some ideas on it. If we look, it says m equals 2, so we're saying 3 times whatever m is plus 4 times whatever P is, and they tell us that M is 2 and P is -4. So this is going to be 3 times 2, which is 6, plus 4 times -4, which is -16. So 6 plus -16 is -10. Now, this is one that a lot of people, number 2, when you look at that, a lot of people ask, well, what is the n squared? And the n squared is just n times n. So that's going to be n times n plus 5. When they tell us that n is 6. So we're going to substitute the 6 in for the n. So we're going to say that's 6 times 6 plus 5, which 6 times 6 is 36, plus 5 is 41. And when we look at what we need to understand about number 3 is that 6p squared means 6 times p times p times p. And they tell us that p equals -4. So that means we're going to have 6 times -4 times -4 times -4. Now by now, when we've talked about integers, we should see that a negative times a negative is a positive, and a positive times a negative is going to be a negative, and a negative times a positive is a negative. So this is all going to be negative. And we can see we have an odd number of negatives. So one of the things some of you have noticed is that if you have an odd number of negatives being multiplied, the answer is negative. So that means we're going to have a negative number, and 4 times 4 is 16 times 4 is 64 times 6, and that's going to be 360 plus 24, so it's going to be -384. So now you can see that this is how we've done the evaluation. You're going to want to know that. You're going to need to practice that. Okay, so I'm going to pause for a minute. Let you write this. You're going to pause it. Let you write these things down so you have these as examples of how to evaluate an expression. Because you're going to need to know these things. Because this is a valuable skill to be able to check and see if two expressions are equivalent. When we get to solving an equation, you're going to have to look at that also. Because you're going to check your answer by plugging in what you got for your solution. You're going to plug your solution into both sides, evaluate both sides to see, do they come out balanced? Okay, so I'm going to let you pause for a minute, write that down. I'm going to give you like 2 minutes to record all this, and then we're going to change pages. So go ahead and pause, and in about 15 seconds, I'll start up again. Okay, so here are some new problems for you. And now that you see that you have C equals 8, D equals -5, and they want you to evaluate these 6 expressions. So some of the most common questions are, what is this? This is going to be 2 times D plus 5 times D. And remember that this is going to be D minus C times C. So go ahead now, you evaluate these 6 expressions. Go. I'm going to give you 5 minutes to do this. Okay, so now you can see what the answer should be. Probably the ones that get the most questions are E and F. What we did with E, well, let's look around. If there's anybody in the room that knew how to do that and got that answer correct, go ahead and take the time to explain that to the class on the whiteboard. I'll give you a chance to pause that, let people explain it. Then in a minute, I will explain it. You can skip past that part. But for those that are watching the video and weren't a part of the class, I'll help you understand because these are the two that probably get the most questions. Okay, so you would have taken on E, it says that D is -5, so you'd have -5 minus C squared, which is 8 times 8, because C squared is C times C. So that means you have -5 minus 64, which is going to be -69. Most people get most people will get like +59 or -59 because they're going the wrong direction. And on F, you would have said, well, so 2 times D is -5, -5 times -5, plus 5 times -5. Well, so that means that if we look, then -5 times -5 is 25, and 2 times 25 is 50, plus 5 times -5 is -25. So 50 plus -25 is going to be 25. Now, guys, if you notice, this is how I've done the work on it. I would say that in your learning journal, you should write down that, evaluate each expression if C equals 8 and D equals -5. And you should have written each one of those separately with the variables so that you have an example in your book and it's not just, if all you see is these numbers, that makes no sense as to what you just did. But if you had all of this and included that you're evaluating each expression, well, then it makes more sense and it's going to help you for in the future when you're trying to evaluate something. Okay, so we're going to give you time to check these, write these, and ask questions. You can have like 2 minutes to finish this, then we're going to move on. So you can go ahead and pause. I'm going to give like a 15-second space here, and then I'm going to stop and start recording something different. Okay, so well, let's just start off with, let's look at this and say, well, what if 2 times, well, how would you evaluate these? We'll go ahead and solve those really quickly, see if you know what you're doing, and then we'll come up with the answer in 2 minutes. Okay, so again, if you wrote these out in your learning journal, you would have written out first just evaluate, written this whole thing out if n equals -4. So we're picking a number to substitute in when we're evaluating. So then in place of the n, we put a -4, so we have 2 times, in parentheses, -4 plus 3. -4 plus 3 is -1, and 2 times -1 is -2. So when n equals -4, then 2 times, in parentheses, n plus 3 equals -2. On the second one, if we have 8 times w minus 2v, if w equals 5 and v equals 3, then we put 5 in place of the w, 3 in place of the v. 8 times 5 is 40, 2 times 3 is 6, 40 minus 3 is 34. Now we're going to play with 2 times n plus 3 in a minute. But it's important that we understand when we evaluated this at -4, we came up with -2. We're going to come back to that. Okay, so the next thing, and this is the important part, this is where we're really going to start using the math that you haven't learned before. So this is very important that you write this down. Now, if your first period and second period, you've played with the blocks already, and so you've seen this and you already had a picture of it. So if you didn't get this written down, write it down now. Okay, so what we said was we'll use this as a variable. We'll call this n. We might call this m. Okay, we call it x. We call this our x. We call this our y when we're using the blocks. If we look at this 2n, two sets of n plus 3, means we're going to have an n plus 3 and another n plus 3. Okay, now we want to look, what do we have altogether then? How many n's do we have here? We have 2 n's. And then how many 1's do we have here? 1, 2, 3, 4, 5, 6. Now, so if you're, right now, this is to give you a pictorial vision of what's happening with this expression. So what we want to do is say this is 2n and this is plus 6. So you could draw this in your learning journals right now so you have a better understanding, because this says this is n plus 3 and this is 2 sets of it. So what we're saying is that 2n plus 3, 2 times n plus 3, is equivalent to 2n plus 6. Now we're going to talk about that with a rule later. When we're looking at this, we simplify that expression. Now what we want to do is check it. We're going to evaluate whether or not these two expressions, 2 times n plus 3 and 2n plus 6, are equivalent. Now, we could go ahead and plug in 4. If I have 2 times n plus 3, is that equivalent to 2n plus 6? We can use evaluation to check and see. Because if these two are equivalent, then whatever number we plug into n should make both sides the same, if these are equivalent expressions. So if these two are equivalent, so now if I plug in negative 4, so I'm going to say 2 times negative 4 plus 3, is that equal to 2 times negative 4 plus 6? So again, this is 2 times negative 3 plus negative 4 plus 3 is negative 1. So this would equal negative 2. And this side, I'm just going to go ahead and draw a line down the middle of this. So I can say, I'm trying to say, are these equivalent? And this becomes negative 8. 2 times negative 4 is negative 8. Plus 6. Negative 8 plus 6 is negative 2. Hey, these two are equivalent. And so what I know I've just done is I've just converted this to this, and they are equivalent expressions, because when I put negative 4 in there, now it's not just negative 4 that will come out equivalent. Let's pick another number to put in there. Because if these are two equivalent expressions, then no matter what number I put in there, it should come out equivalent. This is very important for you to understand on the test, because we're going to ask you, are these two expressions equivalent? And you can either understand the math to it of the distributive property or the combining like terms, or you could plug in a value for each variable, and if they came out equivalent, that would show you know how to test equivalence. This is one of the tests for equivalence. So if I took another number, let's say I took 3. I took 2 times n plus 3, and I'm going to say that's equivalent to 2n plus 6. And I put a 3 in place of the n. So I have 2 times 3 plus 3. And is that, my question is, are these two going to be equivalent? And that's going to be 2 times 3 plus 6. And 3 plus 3 is 6. Times 2 is 12. 2 times 3 is 6. Plus 6 is 12. Yep, these two are equivalent. If these two expressions, 2 times in parentheses n plus 3 and 2n plus 6, if those two expressions are equivalent, whatever number I put in should come out to be the same value on both sides. I can plug the same number into both ends and I get the same value. Now, again, you should have this written and that you've checked it this way and that you've checked it this way. Because what we've talked about now is we can find an equivalent expression using some of the math terms we've already learned. And if we find equivalent expressions, we can check to make sure these are equivalent expressions by simply plugging in a value in the same value into each n, and we can know we've got it right. Guys, on the test, you can now know if you have 100% on the test. Because if we ask you if this is equivalent, if you create an equivalent expression, you can check your answer every time. You can check it to see if the original expression and what you converted it to, if those two are equivalent by simply plugging in a number to both of them. As long as you do your math correctly, you have it. Okay, so I'm going to give you like 2 minutes to write this down, and then we're going to move on to the next step. Okay, so write this expression down. Because what we want to do with this expression is we want to simplify this expression by combining like terms. So go ahead and write down 3x plus 2y plus 3 equals 4x. Now this one's fairly simple because it's all addition, which means we can use commutative property. Now what we're going to do is we're going to draw this one as an x, we're going to draw this one as a y, and we're going to draw these as 1s. So this would be 1 and a 1 and a 1 and a 1 and a 1. So this would be the same as 5. Now the cool thing about if you have graph paper in your learning journal is you already have these little squares. So you can already use those. Now what you'll notice is if you've used the manipulatives, you've already realized that this is not exactly 2 or 3 or 4 or 5, but they're purposely a different length. So you don't give them a unit length. So now you've got that written down. Now we're going to move on to how do we add. So ideally, I'd be able to click and drag and show you what we have and how I got it. And the cool part of using these as x's, and we called these y's, and we called this one. But what I have here is 3x plus 2y plus 3 plus 4x. That's how we would draw this out. If you had the blocks, that's what it would be. And then our next question is, so I'm going to give you a minute to draw this out. But just a minute. Okay, so with this, the next question then is, this is 4x's. So what we want to do is combine like terms. So what we're going to say is, look, these are all added, right? This is added. These are all added together. So that means I can move this and this together. And if I move those together, then what I have is those are 7x's. And then I have only 2 y's. There's nothing I can add that with. And then all I have left is those 3's. So the only thing I had here was the x's. that I could combine. Because if I look, these are the only ones that look like each other. Okay, so you're only going to add like terms. And so our next step is going to be, we want to check and see, did we do this right? Are these equivalent expressions? Okay, so I'm going to give you a chance to write these down. So they're going to pause it for a minute so you can write this down. And then we're going to switch over to how do we evaluate these two expressions to make sure that they are equivalent. Okay, so if we say, let's just pick a number, if x equals 2 and y equals 3. And we don't want y and x to equal the same thing when we're evaluating this, or else we might have made a mistake, we won't catch it. So we want these to be two different numbers. And so if you have this, then we're going to put 3 times whatever x is plus 2 times whatever y is plus 3 plus 4 times whatever x is. And we said that x was going to be 2, and we said that y was going to be 3. So now if we simplify this, we get that this is 6 plus 3 plus 4 times 2 is 8. So this is 12 plus 8, which is 20. So this is 23. Now, if we've done this correctly, if we've simplified this correctly, we should get 23 when we plug x and y into these. So we're going to have 7 times x plus 2 times y plus 3. And we said that x was 2 and y was 3. 7 times 2 is 14, plus 2 times 3 is 6, plus 3, 14 plus 6 is 20, 20 plus 3 is 23. Oh, look, they're the same. Now, just in case you're wondering, maybe we did something off, and what about if x was negative? Well, let's say x is negative 4 and y is positive 1. So we'll plug that in. We have 3 times negative 4 plus 2 times 1 plus 3 plus 4 times negative 4. And that means we'd have here, this would be negative 12 plus 2 plus 3 plus negative 16. This is positive 5. Positive 5 plus negative 12 would be negative 7 plus negative 16, which would be negative 23. That's just coincidental that it's the opposite of this one. And if we looked at 7x plus 2y plus 3, and we do the same values, we put 7 times x plus 2 times y plus 3, and we put negative 4 in place of x, and we put 1 in place of y. Then we get negative 28 plus 2 plus 3. 2 plus 3 is 5. Negative 28 plus 5 is negative 23. Oh, look, they're still the same. If we've done our work correctly, if we've simplified this expression correctly, we can check to see if these two expressions are equivalent by plugging a value into x and another value into y, in both the same value into x across both expressions. And if those two numbers come out, if the two evaluations come out to be the same, then we know we have an equivalent expression. Okay, so I'm going to give you a moment to write these down. And so we're going to pause, and we'll go from there. Okay, So now let's say we have 6n minus 1 minus 8n plus 9. We want to combine like terms. If we look, we're going to call these n's now, and these are still 1s. So now this makes things a little different because we're throwing subtraction into the picture. And we talked about what we want to be able to do so that we can compute like terms. We want to rewrite this as an addition statement. So again, what we've talked about in class is we would say this is plus negative 8. So we would rewrite this as 6n plus negative 1 plus negative 8n plus 9. Okay, so make sure you've got that written down because we're going to draw this now. Again, if we said these were n's and these were 1s, you might be asking, well, what are we going to do with that? How are we going to get the negatives? How do we draw negatives? There's a couple ways we could do that, but I'll show you that right now. So get ready, pause for a minute. Okay, and so now what we're going to do is we're going to say that on this side, up here is positive, down here is negatives. So we rewrote this as 6n plus negative 1 plus negative 8n plus 9. That was so we could commute. And if we look, here we have 6 n's and negative 8 n's, and we have positive 9, and we have negative 1. Yeah, everything on this side is negative, everything on this side is positive. Now, one of the things we can do when we're looking at this as a pictorial is we can say, well, let's see what we have. We have 0 pairs right here because these cancel each other out. These make 0 because negative 6n plus positive 6n gives us 0. And if we look right here, this gives us a 0 pair also because negative 1 plus positive 1 equals 0. And so now what we're going to do is we're going to simplify it. And what we have here is these are negative 2n plus, and we have positive 8. Now, away from the abstract, we could have just said, we could have said, well, we have 6n plus negative 1 plus negative 8n plus 9. And now we use commutative property to put these two together. 6n plus negative 8n plus negative 1 plus 9. If we have 6 plus negative 8, that gives us negative 2. And negative 1 plus 9 gives us positive 8. This is negative 2n plus 8. So, of course, the next thing we want to do is we want to make sure we have this right. So make sure you have this written down. I'm sure you have a few questions. And we'll talk more about this another day. I'm sure you have more questions. So write this down. And so she'll pause for a minute so you can watch this, write it down, and then we're going to go back to evaluating these two expressions. Okay, so now as we evaluate this, let's just make it simple. Let's call n equals 1. So I'm going to take and say I have 6 times n minus 1 minus 8 times n plus 9. I want to keep this in the original form because if I made a mistake somewhere in my transition of making everything addition, I don't want to reproduce that mistake. So I'm going to keep this here, and I'm just going to put a 1 in here and a 1 in there where the n's would be. So now I go 6 times 1 is 6 minus 1 minus 8 times 1 is 8 plus 9. So 6 minus 1 is 5. 6 minus 8 is negative 3. Negative 3 plus 9 is 6. And then we said that was equivalent, that these two were equivalent, that negative 2n plus 8 was also, it's the same, it's equivalent to 6n minus 1 minus 8n plus 9. So we're going to plug that in. Negative 2 times 1 plus 8. Negative 2 times 1 is negative 2 plus 8. Negative 2 plus 8 is 6. Oh, look, they are the same. When we evaluate each expression with n equaling 1, they come out to be the same value, which means they are equivalent expressions. This is how we test equivalence. Now, I don't think this is easy. We're going to go over it more, but the biggest thing you're getting out of today is to test equivalence. To be able to simplify, I'm going to give you some rules to remember on how to simplify. We're going to be adding expressions. We're going to be adding linear expressions. We're going to be subtracting linear expressions. We're going to use some fractions and some decimals with this. Okay, but first we're going to stick a lot with integers so that you get the principle of how to add, how to combine like terms. And we need to remember that we're not going to put this stops right here at negative 2n plus 8. We don't go any further. Okay, let me give you a moment to, now if we were to, let's think if we were to evaluate that with n equaling negative 2. So we'd say 6 times negative 2 minus 1 minus 8 times negative 2 plus 9, or plus 9. This would be negative 12 minus 1. And then negative 8 times 2, negative 2 would be adding 16 plus 9. So negative 12 minus 1 is negative 13. Negative 13 plus 16 is positive 3. 9 plus 3 is 12. Okay, and then if I go back to our original equation up here, we had negative 2n plus 8. So if we're going to substitute in, we have negative 2 times n plus 8, and we said that we're going to have n be negative 2. Negative 2 times negative 2 is 4, plus 8 is 12, and they're equal still. Now, notice they have different sums because we use different numbers. But as long as they're equivalent expressions, as long as 6n minus 1 minus 8n plus 9 is equivalent to negative 2n plus 8, when we evaluate them with the same number going into n, they will come out to be the exact same value after we've evaluated each expression. What we're talking about is, are these equivalent expressions?